of the agenda, we'll go through the quick introduction to the data modeling and levels of it, and some key principles and best practices and some pitfalls around it. And let's have a quick introduction to it. So the data modeling, it's an approach which organizes data into a logical format, which makes it easier to understand and manage across the organization. And it also improves data quality by reducing the redundant data points and errors in the system and the storage. And also it supports decision-making by providing consistent and reliable data points. And enables system scalability. It's important for, especially if you're working with a large data set, the data will grow in time, so it's easy to scale it in time if you prefer a well-structured data model. And it enhances communication between both technical and non-technical teams, so everyone can collaborate and discuss the data needs on the same data model. And levels of data modeling, once, as analysts, once we complete the data analysis, the data profiling, and quality checks, we continue with the data modeling approach. We start with the conceptual level data modeling. At this stage, we defined all the concepts in our data sets. We try to understand what the business needs and the terminology around it. And our main users are the business users here. And once the model is identified and we define the certain entities, we move on to the logical level data modeling. At this level, we define the relationships between the entities by also defining the certain data attributes here, and we communicate with the data architects at this stage to make sure our data model is fit with the system's purposes as well. And all the business rules are also defined here, such as to clean up the data or applying some logical transformations on it. And once it is identified, then we populate the physical level data models. This is the final stage in our data modeling approach, which defines all the data types and relationships and all the columns. And this also follows the same columns order, names and data types, which are adhered to our physical tables in our database. And our main users at this stage, communicators, are developers. And then it gets started with the implementation phase. And the role of data modeling in decision-making, it enables efficient access to data by optimizing the storage, the way of how it's stored and accessed and managed, so the users can easily access to the data. And it facilitates collaboration, again, by providing a common framework for all technical and non-technical users. So we make sure that the requirements are understood by our technical teams, and we also align with what the business needs. And it should be adaptable to change in our data modeling. So our model should be flexible for any feature growth or any schema change in the future. It should require only a minimal rework when it comes to change. And it reduces redundancy, but by removing the redundant data points, and it ensures that the system has a reliable data format. And enhances predictive analysis by analyzing past and future data. You would also forecast the future trends as well. And it improves decision quality, of course, if you implement the right quality checks in place and you apply the correct logic on top of it. And then the decision makers will make the right decision by using the transported data. And data modeling, the role of it in system design. So it's data model is kind of like a blueprint in your system. So it is a way of defining how you store your data, how you manage it and access it and organize it. And also, if you define some set of rules, you could also enhance the system efficiency by optimizing your storage, access, and data retrieval by improving the performance. And it supports scalability with your data. When it grows in the future, it will be becoming more and more easy. If you go with the right approach with different levels of details and granularity in your data, you will be able to handle the large volume of incoming data. And it facilitates integration by providing a unified data approach. Imagine that you are ingesting data from different data sources, and you will put them into one table, which you need to make sure that the data types are consistent, and you did the transformations in a right way, and your data is accurate and consistent. So it facilitates a seamless integration between different source systems. And it ensures data integrity and security by identifying the PII and sensitive data and applying the right regulations on top of it. You would secure your data. You could grant access to some certain users to use the data. For example, some column level masking, some encryption methods you could also apply. And you would make sure that the data is insecure. And it simplifies the system maintenance when it comes to a schema change, for example, or if you already prevented the redundant data points, the engineers, they shouldn't need to worry about that much, about the system growth or any maintenance work in the future. And some key principles around the data modeling. The consistency, it sits on top of it. For example, you should be consistent in terms of the data types. And imagine that you have a data type Boolean flags, which shows you if a value is true or false, if a person is male or female. And then another data source might have like yes or no, Y and N, or 1 or 0. Then you should be applying transformations around it just to store your data in a consistent way. So you shouldn't worry about the upcoming data, what format it will be. And in terms of the flexibility, your models should be adaptable to any change in the features, such as schema evolvement. Apache Iceberg makes it quite easier for a data modeler, so your data isn't affected by any schema changes at the source system. And it won't end up in data loss or disruption. So it's really important one. And normalization and denormalization, those are two different approaches. And depending on your business needs, you could go with a normalized approach just to maintain the relationship between your entities. However, if you have non-technical users and you would like to see a summary level of data, you might go with the denormalized approach just to improve the system performance, or easy querying and easy analysis for the end users. So both of them are correct, and you could apply them to any type of business needs depending on your system requirements. And the documentation is also an important one. You should be versioning your data models and documenting all the steps in your data dictionaries, your data models. You should increment the version of the documents when you make a change. You could also store them in repositories or in your storages, so you have all the changes in one place. And in terms of governance and security, identifying all the sensitive information and applying the right policies on it will make your data more manageable and insecure. For instance, GDPR is one example of it. You should just make sure that you are aligned and adhere to any regulations such as GDPR. And we generally define these rules in our data dictionaries. And then we'll pass the requirements to the engineers for masking and any other policies. And in terms of some best practices, please don't create any redundant data points. It makes this system horrible, and you shouldn't overlap any data points. For instance, if you are storing any customer information, name and surname, just store it in one table and don't create them in other tables as well. So centralize the information only in one place. And rely on business capabilities. Your business users is your key ones. You should make sure that you align with all the teams and you understand all the requirements clearly, so you apply the correct transformations and rules on your data. And long-term stability is also important. For example, if you have a customer data table, same example again, and your CRM team, if they decide to change their ways of working or their structure, your customer table shouldn't affect any organizational changes. Only the major changes should affect them. And in terms of cross-organizational, we shouldn't be specific to any certain parties, and our data model should be common and generic for everybody in the organization, so everyone can make use of it, and you don't need to change it anytime when a new requirement comes in. And it should go with a breadth approach rather than the depth. Creating different levels of data layers is important. If you have different types of user profiles, you could go with a base level data model, and then you could create another consumption layer on top of it. And you could also create another summary level, which is purely for the business users, non-technical ones. This makes the life easier for the users. However, it might make your system more complex, so it's suggested that we shouldn't go for more than 3 layers in a data modeling approach. And involve relevant parties in your process. It is important that because, for example, if you're creating a calendar table in your system, then you should also align with the finance team requirements and the operations teams and other teams. So you should analyze and communicate with all the parties carefully during your process. And common pitfalls in data modeling, so lack of granularity. It's a very important one because yeah, for instance, if you have a table which you store your monthly sales, and then on Monday another user can come in and I want the daily sales reports as well. So it will be very a nightmare for them to query the data, take the required information. Maybe they would need to go to the base level of your data modeling, and then they would have to join so many tables together to retrieve the information. So make sure that you have the granularity in your data sets, and you are also capturing any upcoming feature needs as well. And inconsistent naming conventions, quite important. Just go with one approach, define the naming rules at the beginning of your analysis work, agree with all the stakeholders, so, and apply it across the entire system. For instance, if you have a customer ID field, if it's a Pascal case, and then just go for it, it shouldn't be Snake case in anywhere, because it will end up with errors in your system. And poor taxonomy. Taxonomy is very important. It's a process that we define all the required entities and attributes and their relationships before we start doing data modeling work. And we understand the business terminology, what that means according to the business. For instance, if you have a database, a property management database, some business teams may call the property as flat, some of them garages, some of them different. So you could go with property as a unique naming convention here, and make sure that it's documented clearly, so every business users would know it's the same information, and they would know where to find this information in your system. And data integration and validation issues. It's last but not least important that applying some certain validation rules and quality checks is also important. You could implement some assertions on your data just to check there is no redundant data points, or your primary keys that defines the uniqueness in your table, they are unique. Even if it's a historical data table, make sure that there is just one active and valid data point at a time per record, things like that. It's also important to define and implement some validation rules. So the issues are not hidden, and they are monitored and reported to the required users. And yeah, data modeling is very crucial. It's kind of a bridge between the design and the implementation phase. And the role of data analyst is big here to make sure that we are capturing all the requirements needed and our technical team understands what we need. And it, of course, empowers all these data governance, data management processes, and it enables the seamless system integration when it comes to working with large data sets or different data sources. And by following these best practices, you would ensure that your data model is robust and open to any future changes. Of course, these are not the only ones, these key principles, best practices, but there are also others. These are just the basic examples that I could summarize so far. And yeah, that's it. Any questions, I'm happy to take. Yeah. I appreciate that it's a little bit abstract session after all of the information, invaluable information. Yes?
Can you recommend any tools to kind of...
Yeah. There are so many tools that are free, or some of them as trials. Most common ones is Irwin. It's very capable of handling any complex data models. You could generate your physical data model by using your logical one. You don't have to recreate all the tables. Or, for example, if you have a data dictionary that you define all these source to target mappings, data types, transformations, rules, and so on in an Excel format, for example. You could write a Python script to read and parse the information, and then it would convert it to a tabular format in those tools, which you don't need to manually create them again. And you could also do some reverse engineering by generating DDL scripts, which makes the engineer's life easier. That I know. Irwin is the most popular one I worked with so far, and also DB schema. It's also nice. However, some of them has some limitations. For example, at the conceptual level data model, there is no need to include any attributes in your table because it's the way of communicate with the business to understand the general terminology and concepts. However, DB schema has some limitations. You cannot fully hide the at least primary keys and foreign keys in your table. It's kind of a limitation of it. But yeah, it's cheaper than the other ones. But yeah, totally depends on your client or your requirements. You might go with the right approach. Yeah. Yes?
Hi.
Hi.
When you were talking about best practices, you mentioned breadth over depth. You said no more than 3 levels. Is that applying to normalization, or is that just in general applying that ethos?
Just in general. So let me give you an example from my recent experiences. We unified our data from different data sources. So we ingest it into a cloud environment. Then the format in one system could be in JSON, in another system could be in another format. You could just store them as they are in one layer, just for efficient storage. And then you could flatten them into a tabular format by putting them into just a single table. This would be your data lake. And then you could handle the amount of growing data as well. And then on top of it, you could create a base level data model. And imagine that if you have thousands of different source tables that you need to ingest and model, then it's not quite right approach to go with the facts and dimensions in your model, you could create a relational data model instead. And then you could create another data set layer for any types of usage on top of it very easily. With a high performance. And your consumers, data consumers would be data analysts, for instance, technical ones. But if you have non-technical ones, you might also want to summarize it into another level for easy reporting, which could be another layer. So yeah, totally depends on the requirements. But yeah, in your approach, you could create normalized one at one layer and a denormalized one in another layers as well. Yes, one big table. So by using the source tables, you could join all information together. For example, you could report your sales against all the regions per this customer profile on this region. So it will be just one big table, a denormalized one. Yes.
I think we have to move on pretty soon, yes. So maybe last question.
Okay, so would you say that in the last layer, would be a good idea to have a star schema in the involved style, classical style?
Yes, that's also applicable, but if you already created your dimensional tables in an earlier stage, you wouldn't need to move them into another layer just to avoid redundant data points and yeah, otherwise it will be costly. There will be no need, but in the top layer, generally there is no need to apply star schema. It could be just one big fact table as well, a summary level data table. Yeah, thank you. There isn't only one approach. Of course, there could be many depending on your needs. I think, yeah.
Fantastic talk. Thank you so much.
Thank you so much for listening.